Okay, so I just want to point this out. Today we're going to be doing intro to R. So it's going to be really important, especially some points of today that you're able to understand and especially follow along. My goal is that everyone can follow along. So that is what I really want to happen today. If you're falling behind, if maybe I'm too fast or it got stuck somewhere, please let me know. Again, the goal is that we can all follow along. So if you have issues, let me know. So this is the same folder. I'm just showing you here the same folder that you downloaded from GitHub. So I have some extra things you don't have yet, but if you want to open this folder, go on class code. We have a partially filled script that I share with you that we're going to be working off of that. So if you just want to double click on that, that should launch your RStudio environment. You should, maybe yours looks a little bit different than mine, but it should have RStudio being launched. Was everyone able to get RStudio launched with your script appearing on the top left up there?
Sorry, Professor, I have a problem.
Yes, go ahead.
I don't see any script. It just says DS store. It's not a script.
What is anyone else not having the script there?
Me, do I think I downloaded it? You may upload it.
Yeah, maybe you downloaded the GitHub repository before I posted it. So you would probably just have to go up and do the same step from GitHub. Then you should be able to see that.
All right, I'll try to do that.
Yeah, if you and it's okay if you do that, because we're going to be talking a little bit about some other things before we actually get to the coding. So you have some time to catch up.
Mhm.
Anyone else, was everyone else able to launch that script with RStudio?
I think. Yeah, I don't think so. I just put a whole other. I just launched RStudio. I didn't know it opened. Awesome. Yeah. So if you try to build again and see if it pops up on Studio. So normally you would already open already in RStudio. I think from now on it probably will do that, but it doesn't even yet. So you might just all these your computer, you can just go ahead there and that was it. Yeah, so just something there. Good. Everyone else good? Very happy. So just so you don't the entire repository. And then that's it. You can just go ahead and do that. Okay, everyone here. Yes. All right, I got it. I'm just following all these stuff here. Right here. Yeah, it's. I mean, you can just skip that for now. Yeah, you can just if you want to go ahead over where you download it. So the looks like here, class code. So there. Yeah, that's what you're going to have. Everyone else here now, things doing all right? Okay.
What about online? Was everyone able to pull something similar?
You good all set?
No, I'm still getting you get our order.
Are you good? Sarah, are you good, Sarah?
No.
What's your name?
My problem first is that I cannot see the color blue,
Yeah,
so
Give me
I
that.
don't know.
We have a student in Tifton who's colorblind and cannot see the color blue.
Okay, perfect. Thank you for sharing that. Let me change that. This down.
Thank you.
Yeah, no problem.
But which colorblind is it that, what other color you get? Is it green?
Something like, it depends. Some shades of blue.
Yeah.
Purple.
Most people are colorblind or unique on that.
yeah, red, green color blind is only a male dominant trait.
Is that better? Can you see that? I
She
mean,
said she can.
But Ethan is red, green.
let me see if I can find one that doesn't have blue. Oh, that's kind of too much. Can you see the blue in this one? Oh, okay, sorry.
We're good.
Okay, perfect. I'll use this and then we'll make sure that that everything is all right after class.
Yes,
Okay.
sir.
Everyone else, so I heard someone in Tifton maybe or Griffin that was having issues here. Is that still the case?
All right, script.
We opened the right file in the our script on our studio is matching yours right now,
Okay,
except for the fellow that can't even get it to pull up. Other than that, we're good.
perfect. All right, so I think everyone is on the same page now. So let's get started here. So, so this, what you're seeing right there is an R script. It's a .r file type. We're going to be working with that today as we introduce R to you. So let's just get started here. Something that we already talked about is on the previous class. It's just to have, this is the website where everything is going to be posted, including today's recordings and code and everything else. And so, just make sure you bookmark that website because it's going to be very important for you. Okay, so before we actually start talking about R, I wanted to take a moment here and ask everyone to change some settings in our studio, as we move in the course, so you understand why we're doing these. But so first thing, if you come on tools, and then you go on global options. So general tab, workspace. So right there, general, here in the workspace. If you have this checked, please go ahead and uncheck this box. So this just makes sure that you're not saving what you're doing in R as far as your environment from one session to the next. And it's going to become more clear why that's important as we do more data analysis, but I just want to make sure everyone is starting off right. So that was one thing I wanted you to change. And the second thing would be, so it's still here, we go to R Markdown. So it would be this tab down here, R Markdown. If you go there, let me see. Show document outline. So that would be, so right here, the showing document outline. So again, I went to R Markdown here on the side, and then the showing document outline. I want you to have sections and name chunks. I know this doesn't make too much sense now. It will very soon. So once you do that, you have to click apply and OK, and then we're good to go. If you haven't been able to do those things, the instructions are here on the code, so you can do that later as well. But I just want to walk you through first so you can see how that would look like. Okay, so what do I intend for you to get from today's course? Today's class. Let me just do something here. All right. So first, we're going to become familiarized with R&R Studio. We're going to learn a little bit about R terminology and syntax, understand a few different object types that are going to be used throughout this course. Just create a very simple data set and explore it with both numbers and graphics. And then learn about a little bit more advanced concepts in R Studio, which is using R Studio projects and setting up directories for when we're actually working with our own data. Okay, so there's going to be a little bit of talk here just to get you introduced to the topic. So why do I personally like R, and why am I teaching R to you and not something else like ArcGIS, QGIS, or maybe even other programming language? So R is a free software that runs on different platforms. So it goes from Macs to PCs to Linux. It's very, very flexible in that sense. It has a very strong online community and support. So if you ever have an issue doing whatever you're doing in R and you just go online and say, how do I do X in R? You're probably going to get an answer that someone else already asked that question and get an answer right there. There's continuous development, and that means that there are new packages coming in every single day with new functionality, new analysis, new code that is available for you. And perhaps one of the main ones that I want to stress for you today is reproducible research. So what is reproducible research? Especially for those of you in grad school. So if you go and collect your data, do your analysis, publish a paper, and then I send you an email saying, hey, can you tell me how you did things? Perhaps your material methods are not, very, very detailed, at least on the analysis side, and ask, can you tell me how you did this part? And, perhaps you can tell the person, oh, I did in Excel and I changed this column to that and I renamed this to that and so forth. But that's not very reproducible, right? And even then, like, think of you when you're handling data in Excel or any other point and click software, each thing that you do, how easy would it be for somebody else or even you in the future to replicate all of that, if you have to, if you're just doing things by point and click. So really having a programming language where everything you do is being documented by the code itself already increases reproducibility. And if you maybe in a year ahead need to do the same work you did, a year before, you know what you did exactly because you have that written in code. This is a very important issue in research, more generally speaking, like in all research, not just ag research. But there's some very interesting examples from the medical sciences where, like, there's this huge paper that was published about cancer that people out of Duke University developed an algorithm that could could predict what was the best diagnosis for a given patient. And then people were using that on hospitals, were actually applying to patients, only to, after a few years, learn that algorithm they developed could not be reproduced by another team. They went after it, tried to understand why, and it was really because they were changing some things in Excel that nobody took note of, and just passed the data on to a grad student, to an undergrad, and all the way through the entire system. And multiple errors happened in that analysis to the point where they actually had to retract the paper, stop all research, all diagnosis being made to patients because the algorithm was doing wrong predictions because of lack of reproducibility. So that's a very strong case. Of course, we're not dealing with cancer patients in our research here, but it's just to give an example of why having reproducible research is important and R is one of the tools that can help us do that. Okay, so now, just so we understand, if you think of R itself, R is just like this little window here on my bottom left side of the screen. So this is what R is, and everything else around it is R Studio. So R Studio basically just brings together different components of an analysis on the same window that makes it a lot easier to work with. So if you only launched R, it would just be the console, which is here, which is basically where the magic happens, is where R interprets what we're telling it. So it is a very important piece. But R Studio brings different panels with it. So we're seeing here our script right above the console. We're seeing here on the environment, which is where our objects and variables are going to be start to appearing as we create them. And we have this last panel here, which has a whole bunch of things going on. But one of the things that happens over here is every time we create a plot, it will appear on this side of the screen. So it kind of combines all the components of the analysis into one window, and that's very, very important, very helpful. And also has colored syntax. So here you can see on our scripts, when you want to make a comment, you do that by using the hashtag. So just one hashtag is enough. I was just trying to create some different levels there as far as indentation, but just one hashtag for a comment is enough. And everything that is not preceded by a hashtag is interpreted by R as code. So if I were not to have the hashtag here and I run this, send this line of code to the console to be interpreted, R would give me an error because it's like trying to interpret, words, not code itself. Okay, so let's, now is really the time where you're gonna start helping me to code here. We're gonna code along. And we're just gonna start very, very slowly here. So the first thing important for you to know in R and probably in other programming languages that you may encounter is the concept of an object. So one thing that I want you to, and please type along with me, this is gonna be important for you to learn as well. So one thing that any programming language is great at is just being a calculator, right? So if I just wanna, try to calculate something, let's say 48 divided by 13. So this number is here on my script. Now I need to send it to the console to be interpreted and get an answer. So one way that you can do that is if you just have your cursor on this line where you want to send to the console. On Macs, I push Command Return and this sends to the console. On PCs, it may be Control Return. If anyone can try and tell me if that's right. Control Return?
Yeah, that's right.
Perfect. Thanks, everyone. So Control Enter is what sends that line to the console. So when I do that, I just want to do again. I'm going to have my cursor in that line. I push here on my Mac Command Return. It sends that to the console, and then the console prints the result. Right. So that's the result of that formula or that calculation right there. Now, what if for some reason I want to use this number in the future? I want to save this in a way that I can use it afterwards. So we can assign the result of this calculation to an object. So let's call this object here A. In R, when we want to assign a value to an object, we use the notation less than dash. So this basically means that whatever we put on the right side is going to be assigned to whatever is on the left side. That's kind of how you would read it. So let's say if I want to, I'm just going to copy this mathematical notation here and paste on the right side of the assignment symbol. And I have my cursor blinking there, I'm going to push Command Return. Notice what happened. I sent this to the console, right? So here's on the console, but I did not get an answer back. I did not get the result back. Also notice that now in our environment, there is a variable, there's an object called A, and it's telling us that A has this number here. So now if I wanted to actually print A to the console, you can just type again A, and you can just run that, and it sends A to the console. R notices that there is a variable, there is an object called A that has a value in it, and then it prints the result to us. Okay, so again here, A is an object, and to assign any value to an object, we use this assignment symbol. You can always, so R accepts both this or equals. Equal can also be used interchangeably. I prefer to teach this just for style reasons, but if you feel like using equal, it's up to you. Okay, so what if I actually, the object A has just one value, right? What if I actually wanted to save multiple values to an object? How would I do that? So let's do that here with object B. So we use the assignment symbol again, and let's say I want to give it 3 numbers. So let's say 10, 15, and 3 that I'm just separating by comma. If I run this, it's not gonna work. It gave me an error that, I mean, if you just read the error, it doesn't really make much sense. But here's the trick. So every time you give in a sequence of numbers or even of words, you cannot just give them like that. You have to wrap them around a function called C. So if you just type C and you open parentheses here and close at the end, C is short for concatenate. So you're basically concatenating a series of numbers and saving them to, or assigning them to that object. So if we run this now, we see that it goes to the console, we got no errors, and B appears on the right side again on our environment. And if I just want to print B again, just to double check that it has what I wanted to have, I just type B and run, and then it returns to me the three numbers that we assigned to B. Okay, so this concept of using the C function, which again stands for concatenate, is going to be really important for us as we do more complicated things. Okay, so up until now, we've only assigned numbers, right? But that's not the only thing we can do. So now I just want to show you a quick example of how you would assign a word or a character to an object. So just use that assigned value there. And if I just write something, so I'm going to write precision ag. If I just write that, it's not going to work. So every time you give it a word or a character string, it has to be given within quotation marks. So you open quotation marks at the beginning and close at the end. And then you can just, if you run that, we see now that we did not get any errors on the console, appears in our environment. And again, if we just type C here and send it to the console so it prints it, we get that character or those two words back. Okay, just want to take a very brief moment here to ask, is everyone following along? Everything all right?
Yes, everything is good.
Okay, perfect. Awesome. Okay, so the thing is, very rarely we actually work with data that is this way, that it only has one or maybe a few numbers or maybe just a word. Normally, data is embedded in a data frame, and that's the most common way that you're going to see data in R and any other programming language. So let's create here a data frame. So if you come down to this piece of the code here, we're going to use the assign symbol, so less than and dash. And then there's a function called data.frame. And I just want to point out here one of the other good things about using RStudio or perhaps a different integrated development environment, which is you get syntax suggestions. So as I start typing here, so R is really showing me a whole bunch of functions that I may be looking for. I'm looking for the data frame one. So what we're going to do here is I want to have a column in this data frame that I want to call number. And inside functions, we never use this assignment symbol. We always use equal. And that's why I like to use the assignment symbol here, because then we differentiate between being inside or outside of a function. But so here, if I want to say that the column number is going to have some value, I need to use the equal sign to assign that. And then I just want to put this string or this object called B. I want to assign that to this column that I'm calling number. And also I want to have another column. So I add a comma here. I want to hit return a couple times just so the code breaks better for us to see. I want to have another column that I want to call ID. So that's going to be the name of the column. And I say equals, and I want to assign the C object to this column here. So if we run this, so if you have your cursor anywhere in these three rows, so anywhere, you just hit, again, Command or Control, Enter, it's going to send to the console. We did not get any errors, which means that it worked. We see again that now we have another object here on the environment called D, which is the one we just created. And let's just go ahead and print it. So to do that, we use we just print the name of that object, and we see the result here on the console. So we do have a column called number, right, which has the three numbers that we gave it, which came from that object B. And we also have a column called ID. But notice something here that you're going to see in R and sometimes can be important to be aware of this behavior. So if we look at B, which we're assigning to the column number, actually had 3 numbers, right? However, C only had 1 value, right? It was just precision ag. It didn't have 3 words or 3 sentences. It was just 1. So what R did is it made a data frame where it included those 3 numbers on the column number, and then the ID basically just recycled to fill in those gaps for us. So that's just a behavior that R has. Okay, so we're going from very simple objects with just 1 value or maybe a few values to now combining them into a data frame. And now I want to show you another type of object in R, which is a matrix. So I do not expect you to use matrices too much unless you're really into mathematics and the algorithm development side, which I don't, maybe you are, but most people are not. But why am I showing you this if you're not going to use this? Is just so you are aware that this exists. You may come across this eventually, and at least you know what that is and how it works a little bit. So to make a matrix here, let's do again the sign symbol. There's a function called matrix that we're gonna use. So this function here, what I want to do is give to this function the object B. So remember, B has 3 numbers, right? I'm just going to print here for you to see. B has 3 numbers. I want to give these 3 numbers 2 times. So I'm going to use that C function. That means concatenate, and I give B and B. So notice now I'm concatenating the same object, which we haven't done yet, but just so you see how we can do that. And I want to add a comma, and there's an argument here for the number of columns of this matrix. I want to say, and that is ncol. So I want to say ncol equals 2. So if you run that, if you had all of your parentheses right, your commas right, you should be good. It should not give you any errors. And if you just print it, I just want you to see how a matrix is different from a data frame, right? So in this matrix, first, matrices can only have numbers, right? And data frames can have different types of data other than numbers. But also, if you see here, we have columns and we have rows, and the columns are not named. They don't have a specific title to them as a data frame does. So this is basically what a matrix is in R. Okay, so our last object type here that I want to show you is a list. So lists are perhaps more common than matrices, but we will not encounter them as frequently either. Data frames are the main type, so just keep that in mind, but lists eventually come up. So I just want to show you what a list looks like in R. So let's just create a list here. So we use the function list. And now to give the name of a component of that list, we have to give it with quotation marks. So I just open and close quotation marks, have my cursor blinking in between them. I'm going to type number. So I'm going to say number equals A. I add a comma, hit return. I want to create another component of this list that I want to call number. Oops, sorry. That I want to call numbers, so plural. I want to say equals B. I add a comma, I hit return. I want to create another component that I want to call word, and I want to assign C to that component of this list. Add comma, hit return. And finally, I want to add a component called data, and data is going to be equals to D. So if we just run this, it should run all right, no errors. And if we print it, I just want to give you just a moment so you can copy from the screen, and then I'll show you what the output looks like. So I just printed this on the console. This is what it looks like. So printed F. So now it has different components that we know they're different components because they're starting with a dollar sign. So dollar sign number, dollar sign numbers. And we can really see that now a list doesn't really carry if things are matching as far as number of pieces or not. It's just giving us a, so here number is just what A was, numbers has 3 numbers, which was what B was. So we see that we had different types of data within this list, and it's okay. It didn't give us an error. If we try to do this with a data frame, it would not work, right? Because it would not be a rectangular shape, because we have a whole bunch of different things here going all the way from a number to an entire data frame, all within the same object, which in this case is a list. So just wanted to expose you to that. Everyone good up until here?
Yes, everything is good.
All right. Okay, so if you are new to R, I want to talk, I mean, this is going to be very important for you to understand. It's just some of the language that we use to describe certain things. So the first one is going to be a function. So what is a function in the first place? So a function is just going to be, it's going to have a name, and it's probably going to take some inputs into that function, and it's going to do something specific for you that that function was written for. So let's explore here the first function that I want to dive into, which is called mean. So let's say if I wanted it, just to remind you, so the object B is 3 numbers, right? Let's say I wanted to know the average of those 3 numbers. Let's say maybe they are 3 reps in your study and you want to just calculate the average of those numbers. So we use this function called mean. How do we know this is a function? A function is always, there's always a parenthesis that comes after the function name. So that's how we know that this is a function and not, let's say, an object, right? I can have an object called mean if I want to. Let's say if I wanted to name something mean, I could still do that, but then it would just be like this, right? If I had an object called mean, it would not have the parenthesis after it. So we know it's a function when the name is, there's a parenthesis that comes after that. And eventually that parenthesis has to close as well. Okay, so if I just run this on my console, for some reason it's just pulling it up, but you can see that it's printing on the console the mean of those 3 numbers, right? So this is what this function does, basically gives you the mean of a sequence of numbers. Now, functions also have arguments. So what is an argument? It's basically one of the options you can change within the function if you wanted to do something different. And each function is going to have their own arguments. So here, if we just check, if I just come here on the function mean and I just hit tab, it gives me at least one of the arguments that it accepts, which is x. X here is just basically what you want to have the mean of. So doing mean b or mean x equals b is going to give us the same result. Okay, so one thing that's really important is, especially sometimes, and this happens to me a lot, like I'm doing something in R, I'm trying to program something, and the function is not working for some reason. How do I know what to expect from it and what arguments can I change? So there's a function called help that I want you to explore. So help, and then you can really enter. So we open and close parentheses, and then it just give it the name of any function that you want to know more of. So if we say help mean, notice here on the right side, there is an entire explanation about this function, what it does. So normally it gives you a general description, and it has every help we ask for any function is going to give you the arguments list. So we see here the 3 arguments that at least this function has. So x would be the object with the numbers of containing the numbers you want to get the mean of. Trim is just let's see, this is basically if you for some reason you want to remove some of the values before it does the average, you can say here using this argument trim. And then na.rm is if you have NAs in your data and you want to remove those NAs before calculating the mean, you have to say na.rm equals true. So all these are the available arguments for the function mean, and I learn about them by asking help mean that way. Okay, so I want to show you something here, and why am I going to this example with you? So let's go ahead and create a new object, which I'm going to call B2. So we say B2 assign. We're going to use the C function because I want to give it multiple values. So the concatenate function, and I want to give it the values 10, 15, 5, which is the same as what B had before. But now I want to introduce an NA. So if it has to be uppercase, so we type NA uppercase, and R understands that that is not available. So it's a missing data, right? So let's say if maybe in your studies, I don't know, you had missing data for some reason, you would have NAs in your data table. So this is something common to happen. So I just want to run this. So send this to the console and make sure that we have B2 available as an object on our environment. And now I want to get the mean of B2. So look what happened. Remember, B2 is the same as B. The difference is that it has an extra NA component to it. So when I ask the mean of B2, I get it returns me NA. And this is a default behavior in R, is whenever you have NA in a sequence of numbers, maybe you have a column of your data frame that you have NAs for yield or something. If you have NA there and you ask for the mean, R will return you NA back because you have NA there. Now, it's kind of silly, right? Because I mean, we do know the numbers are there. So let's say if I just wanted to ignore that NA and still get the mean of the values that are still there, how can I do that? So R, I'm sorry, not R, but the function mean, as we were seeing on the documentation, it has this argument here called na.rm. So meaning that we can remove it. What happened if I just type comma here and I just say, so this NA remove is by default is its value is false. So it's like a logical is either true or false. The default is false. So what if I actually wanted to make it true? So just type T, or if you want, you can type true completely, but it has to be uppercase, but just T is enough. So if I just change that to T, that should give me my mean. Okay, what happened here? So if I run that way, what I'm doing is giving the first argument as B2 and the second argument as true. It's giving me an error, and here's why. If you do not name the arguments that you're giving to the function, it's going to try to plug them in the order that is on the documentation. So right now it's assigning B2 to the argument X, which is what we want, but it's assigning true to the argument trim, which is not what we want. We want to assign true to the argument NARM. Meaning that if we want to do that in this case, we have to be specific of which argument we are changing here. So to fix that, we would say mean, let's say X equals B2, comma, NA.RM equals true. So we are explicitly calling the name of the arguments and then giving the value that we want. So if we do that now, we do get our correct average back. So it's basically removing the NAs first and then giving us the average of B2, which is what we want. So this is just to call your attention to, you know, it's so I do all the time, like with functions, especially functions that I know already how to use. I just give like the inputs that I know are needed. But sometimes if you get an error, it may be because you're not giving them in the order that the function is using them, and it's just using in a way that it's not working. So always check the help if that's something that happens. Okay, so we talked about, you know, simple objects, including one number, few numbers, a word, creating a data frame with different columns and assigning values to them. We saw how a matrix looks like, how a list looks like. Talked about what is a function, what makes something a function. We talked about function arguments and how most of the time you're probably okay just saying mean of B, but sometimes you have to say mean X equals B or something like that to make it work properly. So now let's talk about package and what is a package and why are they important and why it would be important for all of us to catch up on the packages after today. So you can think of a package sort of like an app, right? So let's say you go online and you search for how do I run a random forest model in R? And then it's going to say, well, there is this package here called random forest that you have to install that gives you a whole bunch of functions for you to do random forest. So a package is just a collection of functions that normally work together around a certain topic. That's what a package would be. Again, you can think of them kind of like as apps on your phone. It just extends the uses of your current R environment and give you more functions within that package to be used. Now, one concept here that is really important to understand is that, at least in R, you have two different ways of thinking of how to use a package. So every time you start a new computer, or maybe you're just starting fresh on your R journey, like some of you may be today, you may need to install a package. So to do that, there's a function called install.packages that you just give a name. I'm just gonna open and close quotation marks and give a name of a package called Tibble. You don't have to worry too much about it. It's just about what this package does. I just want to show you how you would install. And you've seen this function already in the file that you were running before this class. But if we just run this, at least on my side, it's basically installing that package. And I know that it was installed because it's saying that the binary package are in a given folder. So I know it was successfully installed. So normally you only use the function install packages when it's your first time installing it, or maybe that package has an update and you want to be able to have whatever updates were made available. You want to bring those to your computer as well. So you would use the function install packages again, just to bring updates. But it's something you do maybe once or twice during, when you're using R for multiple years. It's not something you install a package every time you use R. Now, this package Tibble is installed in my computer right now, but on this R session specifically that I'm showing you, I don't have access yet to the functions of this package. So that's when loading a package, the concept of loading a package comes in. So I already have it installed, but to make those functions available for this R session, I have to load the package, which we use the function library to do that. So we would say library Tibble. Yeah, I just want to run this out. I'll be right with you. And then it just sends to the console. And now the functions from this package are available for me to use on this R session right here. So we had a question here. You got it?
Don't put manual in install.
Okay. Yeah. And so I just want to make sure that you understand this. So you install once, maybe another time if you want to get new updates from that package. But every time you start R or you launch RStudio to use R, you will have to load a package if you want to use that package. So just to make this clear, you will always see in our scripts, the first top part of our scripts will always be loading packages that we'll be using for that class. So that's why the library function you use all the time. The install packages function you use just that one time when you're installing a package. Okay, so now I want to get into a more, yes. Yeah, so the question here is if we needed the quotation marks here. So it's kind of interesting that on the install packages function, you do need the quotation marks. If you try without it, it's not going to work. You have to have the quotation marks on the install packages function. However, on the library function, so when you're loading the package, you do not need. I just added here just to keep it consistent, but on the library, you don't need. Yeah. Okay, so now here's what I want to do. So we talked a lot about our, syntax and some of the nomenclature. And now I want to expose you to some concepts about data manipulation and graphing as well. So what we're going to do here is I want to ask for your help to create a data frame with me. So I will, I will ask a couple people here in Athens, a couple in Tifton, a couple in Griffin, and maybe one online to give me your name, your height, and your favorite crop. So we make a data frame that we can play with. Okay, anyone here in Athens wants to be the first person to tell me that information?
Bo. 6'3".
Okay, I'm gonna put, because it has to be like a full, like, let's say 6'3" is probably, I'm gonna just transform quickly that to centimeters and put that 190, like 1.90 m, probably around there. May not be super accurate, but that's fine. And your favorite crop? Cotton, okay. Perfect.
Yes, on this.
That. That's eight. Okay. Your height in metric system? 181 centimeters. And your favorite crop? Maize, okay. All right, we got a couple here in Athens. Now let me pull here. I want to get a couple from other places as well. Let me just. I don't know where. Let me check here. Okay, so from Tifton, can a couple people from there tell me this data?
Austin,
All right,
5'10".
so 5'10", I think is like 180 centimeters. And your favorite crop?
Peanuts.
Yes, awesome. All right, let's do maybe let's do one from Griffin. I guess there's just one person there.
It's Anis, ANISH.
Is that right?
ISH.
Sorry, say that again.
ANIS.
And
I as an ice cream.
Yeah. And then height 178.
178. And your
And then the favorite pecan.
pecan. Awesome. Nice. I like the diversity in crops. All right, so let's do Umar. You're the one online.
Yeah, so the name is Omar and the height is 6'4".
Okay, so let's say
That
that's
would be 193, I guess.
193. Okay, so Bo is taller than that. Let's put 195. Okay, and your favorite
Yeah.
crop?
You can say rice.
Rice. Awesome. Okay, and I just noticed here, so if you wanna also, I'll copy this the same way I'm doing. I just noticed I was adding quotation marks to the numbers and I do not want to do that. So the height is just gonna be a number without quotation marks. So what I was doing is basically giving the name within quotation marks, the height in centimeters, just the number without quotation marks, and then the crop within quotation marks. If you all want to follow along this and copy as I have, I think it's gonna be nice for you to have this as we go down the exercise. So I just want to give it a quick couple minutes here for everyone to catch up. And if you want to make sure you got it right, you can just, again, have your cursor blinking anywhere in these lines and hit Command Return. If it goes to the console and it doesn't give you any errors, that's how you know you got it right. If you do get errors, I just want to point out that maybe you're missing a quotation mark somewhere, maybe you're missing a comma somewhere. Those are the most common issues that you may have.
You doing it on my computer also?
Yes.
It says that on this one, like the desktop, says that the R Studio needs to be updated on mine.
Mine might be, I think mine does need to be,
It wouldn't do anything though. Like it said that I have to update it before I can do
because
anything.
mine says was built under version 4.1.3, so which is implies to me that it's not updated.
Mhm. Let's see if this works. Cause mine won't let me use the tabs.
Oh, we're not muted. I have a question.
Oh, so I just thought something. So for those of you that were having issues installing packages, if you were not able to install this package, this may not work for you because the function tribble comes from the package tibble. If that is your case, we can make this work afterwards, if you're having issues installing package. So just to let you know. All right, I think everyone was able to.
Question about they installing the package real quick.
Okay,
When I installed the package, it gave a warning message that it was built under R version 4.1.3.
oh, that's
What does
okay.
that mean?
So if it is just a warning, it's still installing, it's just letting you know about something. But it should still be able to use it. Okay, I'm gonna go ahead and continue here. So if we just want to make sure that, what is it that what we gave this function that we're calling intro is there. If we just run it, it's going to appear here in our console. So again, we have that name column that R is seen as CHR, which stands for character, because we gave it within quotation marks. So it sees that as a character or a word. And then we have the height, which is seen as DBL, which stands for double, which is basically just like a number, is numeric, this column. And favorite crop is again character and with the values that we gave it. So it's all looking like what it should be. So that's great. So I want to introduce you to some functions here that are very simple, but also you're going to be using them a lot as we move through the course. So the first one of them is the function called class. So this function here helps you to know how R is interpreting a given either object or a column in a data set. So what type of object is that? As you saw, we talked about like having a number, having multiple numbers, having characters, having a list, the matrix. So if we want to know how R is seeing that, we use this function called class. So if we just say class, and then we give the name of this object that we just created, intro. So it's telling us, is returning us here, is saying is a table. So this stands for table and data frame. So it's seen as a data frame, which is exactly what we would expect, right? And then another important function that you're going to be using a lot is called summary. So if we ask for summary and we just give it intro, so the name of this data set that we just created, notice what it tells us. So it's basically saying for each one of the columns is giving some type of summary. So for the character columns, name and favorite crop, is just saying that what is the length. So what are the how many values are there. But for the height column, notice what did it give us? It basically noticed that height was numerical, and so it gave us a quick statistical summary of that column with minimum, first quantile, median, mean, third quantile, and maximum. So this is just the behavior of this function called summary. This is going to be really useful, especially if you have very complex data sets. Think of maybe you have, I don't know, 80 columns in your data set. This summary function is really an easy and quick way for you to see first if R is interpreting the columns the way you thought it would, as far as being character or numerical, but also on the numerical ones, it's an easy way for you to browse and see if you have, let's say, if the maximum value of height was 2000, I know for sure that's a mistake, right? because no one is that high. And so you can kind of use it to also see if you have maybe mistakes in your data that was made during data entry or maybe data collection, and you can catch them easily on the summary function, especially if you have lots of data columns. Okay, so I want to, now that we introduced this data frame here and we just checked the class of it and also a little bit of the summary, I want to show you some ways that we can sample this data frame. So let's say if we want only the first row or the first column, or we want a given value specifically, how can we do that in a very simple way? So if you come here to the first row only, and we just type the name of that object, so intro, and we open and close brackets. So notice now it's brackets, it's not parentheses. So the brackets allows us to kind of sample or extract specific parts of the data on the using a given syntax. So you don't have to type exactly what I'm going to do now, but you can think of it as this. This is the syntax that's going to understand where X is the position on the row, Y is the position of the columns. So if I do want the first row only, what I would do is I would say 1 and just leave empty the column position because I want all columns just for the first row. If I run that, it returns only the first row, all columns of it, right? So it returned the values for both. Now, what if I wanted, instead of the first row, I wanted the first column entirely? So let's do intro again, open and close brackets. I just want to put the comma there, and I want to ask if anyone can guess what we would do if I just want the first column. Yes, put the 1 on the Y part. So if we do that and we print it, we get the entire first row with all the names, right? So now let's say I want to do a query that's a little bit trickier. So I want a range of rows and a range of columns. How do we do that? So again, we call the object name, which is intro. When it's a range, meaning that it's consecutive numbers, so 1, 2, 3, so that means 1, 2, and 3, we can use the colon symbol like that. So 1, 3, this is on the row position, then comma, 1, 3, 3, this is on the column position. So if I do that, I get the first 3 rows and the first 3 columns of this data set. What if now I want 1 and 3 instead? So I don't want 1, 2, and 3. I just want 1 and 3. Right. So we'd say intro, open and close brackets. I'm adding the comma there just so we can place our mind of what we're doing. So if I wanted, again, I want rows 1 and 3 and columns 1 and 3. So I need to give the number 1 and 3 on both sides here. Anyone has a suggestion of how can we do that based on what we've seen before? If I just do like 1, 3, not gonna work.
So can we go -2 on both of them?
That's a good, yes, we can definitely do that. I mean, I think so. Let's try. This is not where I was going, but I think, yeah, I love it. Thanks for saying that. It's actually, yeah, so we can, this is just a great example of you can either tell what you want or you can tell what you do not want. In this case, we're telling what we do not want. And it's a great example. It's not what I had thought of, but it's a great way, and also a great way to show that really in programming, there's so many ways of doing the same thing and there's no wrong or right. It's just whatever works, right? As long as we get the job done. But what I wanted to show you here is if we want to give 2 numbers, if they're consecutive, we can use the colon because that basically unfolds into 1, 2, 3. Let me run that just so you can see as well. If I just come here on the console and do 1, 3, that unfolds into 1, 2, 3. It could be 1, 10. It would be 1 through 10 all the way. But if I want 1 and 3 only, I need to use the C function. So I would say 1, 3 on the rows, on the row position, and 1 column or 1,3 on the column position. And if I do that, oh, wait, actually, I think that the -2 didn't work as anticipated. But anyways, we don't have to get into that. But here we really see that we got, so the row 1 and 3, right? So 1 was Bo, 3 was Austin, and we got columns 1 and 3. So 1 was name, 3 was favorite crop. So that's what we got here. And now just looking in retrospect, that if we did the -2, you don't have to do it. I just want to do it again just to show you. It didn't return us exactly that. But yeah, we don't have to talk about that here. But that's a great concept nonetheless, because you will see sometimes that you can select something by saying what you want or saying what you don't want. Okay, so we created this data set. We explore a little bit with using summary, showing you how to extract different values from it as far as row and column position. And now I want to introduce you to plotting in R. So this is a really interesting thing for you to be aware of is, so in R, when R was developed, I think was, I don't know, 20 years ago or so, there was a whole bunch of functions and a whole bunch of people developing things in R, and they were not one team. And what happened is some people developed some things with a given style, and that style was different from other people, but you kind of need to use all those functions. And when you're using functions, they're using different styles of like argument setting and syntax. It just makes it difficult for us users to follow along. So what happened is RStudio, which is the name of this window that we're using here, but is also a company, RStudio started to develop other R packages that follow a similar syntax or a similar philosophy behind it. And ggplot2 is one of them. So ggplot2 is one of the main packages in R. It is a package developed by RStudio, and it's the one that I use for all of my graphs. And I'm telling you, why am I telling you this? Why does it matter? Is because if you, let's say, if you want to do a map in R, and you say, how do I do a map in R? And you're going to come across a whole bunch of answers where some of them are using ggplot2 as the package to do that. Others may be using different packages like base R, or maybe other specific packages for spatial data. But I'm telling you this because ggplot, I want to teach you ggplot. That's the best way that at least I think is the best way to learn. It's very intuitive, and you're going to see it here in a second. So we're going to start using this package called ggplot for making plots in this class. ggplot2 is a package that we already installed. So if you were able to follow the install instructions, you already installed ggplot2. If you did not follow them and you want to install them now, you would use that install.packages, open and close quotation marks, and type ggplot2, and you can install it. If you have already installed, you don't need to do this. This is just a heads up. And but remember that we install once, but we load the package using the library function every time on a new R session. So if you have already installed it, let's just load ggplot2 in this section here. So using the library function. Okay, and actually, before we start using this, I want to ask you all something. So I want to come up here. I just want to print intro again, so we can all see it. And I want to ask, anyone in any campus or online, I want to ask your opinion on this. If we were to create a plot out of this data set, let me ask you this. What do you think should go on X? What do you think should go on Y?
Put the names on X.
Okay, so I heard names on X. Let me just type that here so I remember. So X would be names. What about on Y? Height. Okay.
Height.
So we have height on Y. Yeah, I think that would work. So this is this part of the exercise is good if I have a blackboard, which online I guess I don't really have much of that. But okay, so yeah, so just try to capture, just try to think on your head, if we had a plot where X, we have names on X and height on Y, right? So let's try to do that, to make that plot. So if we use ggplot, the way that every plot that uses ggplot starts is with the function ggplot. So you can just go ahead and type it. The first argument that it has, I just came here with my cursor in between the parentheses and hit tab, and the first argument that it has is data. So data, the name of our data is on the object called intro. I added a comma, and now how do we tell ggplot what goes on X, what goes on Y? It could have been just like X equals this, Y equals that. However, the way that ggplot operates is a little bit different, where if I hit tab again, it has an argument called mapping. And this is where we tell where X and Y, what X and Y are. But we have to tell it through the function AES, which stands for aesthetics. And that's going to be, you're going to understand better why that is the case in a second here. So if I come here inside AES and I say X equals names, add a comma, Y equals height. Okay, I broke the code here just by hitting return. You didn't have to, but I just did to help us with visualizing it better. Just make sure that you have your commas and your parentheses right. If we run this, oh, it actually didn't work. What was it?
I think the X goes for name, not names.
Oh, perfect. Let's just double check that. So if I print just intro, yes, that's exactly it. So this is a great example of like how we need to be very precise when we're telling functions the name of either objects or columns. Thank you for helping with that. Okay, so if we just run that, what happens? So you should have seen this plot popping out on the right panel here, where what ggplot did was, yes, it put name on the X and gave us the levels under that column, and it put height with already the range of values within the range of our data, right? So it's not starting at 0 here. It's already looking at the column and giving us the range of values that make sense. However, it has not done anything else. I mean, where is the data? I mean, there's nothing here to show the height of these different students. So to do that, we have to, well, first, I guess before I do that in code, I want to ask the class again, how do you think that we could show, like if you were to either make, how would you draw on this plot to show where the height of each one of the people are? Would you, what type of shape, I guess, would you use for that? A bar graph?
Bar graph, I would say.
Great, that's a great example. So how do we do that with ggplot? So at the end of this last parentheses, we add a plus because we're going to add more things now, and we hit return. You're going to start typing geom _. So the way that ggplot works is it has a whole bunch of geometries, and the geom is the short for geometry. And if you just type geom _ and hit tab, you're going to have some idea of all the different geometries that you can choose from. It's a whole bunch of them. So there is one that is called, let's see. So there's one that's called bar and one that's called col for column. And one of them works best in this case. Let's try bar first. Okay, let's try col then. Yeah, so it's the col. So it is the geom col one. So what it did is it basically created a column that stops at where the height of that person is, right? Now I do, so geom col is perfectly, it's a perfect one to use for this example. I do want to show you a different one because we will be customizing a little bit more than a bar chart allows us to do. So instead of using the geom col for columns, let's use geom point instead. So very similar thing, just that now instead of having entire column, we're just having a point. And also, you know, something interesting to see is that geoPoint is just adding the point within the range of heights that we have in the data. Whenever you use geomcol, by default, that sets the minimum value on the y-axis as 0. So that's another difference here, but just to, you know, let's stick with geoPoint for now. Okay, so, you know, looking nice. This is the plot that we had. What if, so let me print again intro here. So we have name and we have height, but we have not used the column favorite crop yet. How do you think that we can bring in that third column into our plot? How would you do that?
Maybe name the points. The name on the points.
We could name the points. That's something that we can do. It's not the direction I was leaning to, so I'm not going to show how to do that right now, but we can definitely do that. And we do that in certain, I mean, I've done that a lot with plots that I make. So it's a good suggestion. Different colors. Okay, I like it. That's where I was going. I mean, I like both, but that's where I was going because I want to show you how to do that. So if I come here on geoPoint and I say color equals to, let's say I want to say red. So color equals to red, and I run that. So what happens is it basically assigns the same color to all the points, right? Which is one option that you could do if you're just trying to customize your plot that way. However, it's not what we really want, right? I really wanted color to be according to different levels of favorite crop. Let's say, what if we try come here and say Fab crop? No, doesn't work. So what happens is every time you are mapping a column to something, that something could be X and Y, like we saw here. It could be color, fill, shape, size, transparency, a whole bunch of aesthetics that you can change in a plot. If we're mapping that aesthetics component to a column in our data set, we have to do that inside the AES function. So we could set it up here on the ggplot level and just say, comma, color equals Fab crop. We could do that here. And we could also have done that at the geoPoint level. So we only had to use the AES function again. So we would say color equals Fab crop. You don't have to do both. I'm just showing you could have done either there or here. I'm going to do just, I'm just going to delete one of them because they're redundant. Just going to leave. And now if you do what I'm doing, make sure you delete that comma right there after height. But if we do this, so saying color equals a column name, it has to go inside the aesthetics function. But if you run it, look what we got. So our ggplot already realized what were the levels of favorite crop, already assigned a different color level or a different color to each level, and is already showing here on the plot those different colors with a legend. So it did that, all that just from this part of the code here. Okay, so another thing that I want to show you here on customizing plots is that we can also, so right now we change color, and if you think of it, a point can also have different shapes, right? So let's say if I wanted to further customize this, I could also come here on the AES of the geoPoint, add a comma, and say shape equals Fab crop. If you run that, and if you got your commas and parentheses right, it should work. And this is what we get. So now each crop has a different color and shape, and the decision of what color it was, what shape it was already by default decided by ggplot, and it already gives you a legend with that matches that. Now you can imagine that perhaps if we had a fourth column, let's say if we had, I don't know, state that you were born, and we would have different states, perhaps different countries, we could do shape equals place of birth or something, or whatever we call that column, that you can really start bringing more and more variables into the same plot, right? So this is really, really powerful because, you know, we think that plots are two-dimensional, which, I mean, they are because you have X and Y, but you can really bring in more dimensions with color, with shape, with other aesthetics very easily in ggplot, ggplot2. Okay, so I want to show you a couple more things here and to tell you a little bit more about the ggplot philosophy. So as you're seeing, we started off just with the canvas, right? So if you just run this again, it's just that empty canvas. And then we had to tell ggplot how we wanted to show that data. So as a point, and then we change color and shape according to another column. So now ggplot has so many ways of customizing things. I want to show you just a handful now so you can play around and do the assignment that's coming next. So let's say for some reason, well, for a very special reason, actually, especially, you know, since you know, if we want to use a color scheme, so a different color scheme, because maybe this is not colorblind safe. We want to use a colorblind safe scale of colors. We want to change the default that ggplot gave us. We would add a plus there, hit return, and then you can start typing scale underscore. Because we're changing the color, it would be scale underscore color underscore, and then you can really see a whole bunch of options that you have here. There's a lot of them. So let's use perhaps, so Viridis is a very popular colorblind safe palette that we can use. I want to use that with the Viridis D for discrete data, which this is discrete, right? We have different names and not numbers. So let's just run that and see what it did. So now we basically changed just the color scheme that we were using, and it's changed that to Viridis now. I want to, you don't have to do this right now because we will do on the assignment that's coming up, but I would like for you to play around with different options here and perhaps find one that you like most, you know, that you like better. I'm just showing you some here, but there are others that you can also choose from. So let's just keep with the Viridis D for now. So that is basically changing the color of the points. But let's say if for some reason, I don't really like the style of the plot overall when it comes to like the background color, maybe I didn't like the gray, maybe I didn't like the lines are white or whatever it is. We can come here at a plus, hit return, and we can change, we can change the theme of the plot. So if you do theme underscore, you have a whole bunch of options as well. Let's change that maybe to, I don't know, BW, which I think stands for black and white. So if we just run that, we see that now the way the plot looks is different, right? So it changed. Sometimes depends on the theme that's already preset, but it can change the color of the background, the lines, the size of the fonts, maybe the font type. It's a whole bunch of things that can be changed within the themes. And I just noticed something here that I want to propose is, I'm kind of fine with the way the plot looks like now, but I would prefer to have larger symbols at these points. So we can come here on GeoPoint. You go outside of the AES, so within the last two parentheses there, and it has an argument called size. I think the default is 1, so maybe let's try 2 and see how that looks like. That's a little bit better. Maybe we can do 3 or whatever, it's just to show you. So notice that now I'm changing the size to a fixed number to everything and not based on a column. And that is why we specify that outside the AES function, not inside. We could potentially change the size according to a variable. Let's say if we had a numerical variable that would be yield, and I wanted to show yield, I mean, it doesn't make sense, right? Because we have people, but just think of it, maybe yield, let's say weight. We had weight as a variable in our column, and I wanted to show that somehow I could say, you don't have to do what I'm going to do now, but we could say size equals weight. And then the size of the shapes would be changing according to weight. Just so you see how the difference between assigning an aesthetics to a variable or assigning it to a fixed value for everything. One goes inside the ES, the other goes outside. Okay, so this is basically our plot. I want to show you now, so we have this plot here, you know, it could be a plot that you're using for an assignment, maybe a publication, whatever, a presentation, whatever it is. So we need to get this outside of R, so we can, you know, save this as JPEG or PNG or something that we can use afterwards. R has this or ggplot2 has this function called ggsave. So by default, it's going to save the last thing that you printed or that you ran, which in this case is this plot here. If we had multiple plots, one after the other, is just going to save the last one that you printed. And we have to give it a path for where we want this to be saved. So that path we have to give within quotation marks, so we can open and close quotation marks. And at least on a Mac, I'm going to show you how that's done on a Mac. You can try on a PC. If it doesn't work, tell me and we'll try to see what's going on. You would say, so this symbol is called tilde. We say tilde just to go to the root of your computer. We say /, and in my case, /. So if you do tilde / and you hit tab, if that worked for you, it's actually going to show you what's in there in your computer. I want to go to my desktop. And if you hit tab again, it's just going to show you everything you have on your desktop. But that's not, the last thing you give here is the name of the file that you are creating. So it's not something that already exists. So let's just call this plot1. And if I just call plot1, it's not going to be enough. We have to tell what is the extension that we want to give it. So I want to give .png. So plot1.png is how I'm naming our file, and that's going to be saved on my desktop. Just want to take a quick moment. So if you did this and if you run it, it's going to say saving. And if you go to your desktop, it's going to be there. Before I do go to my desktop to show you it is there, I want to ask if this relative path here worked for everyone, especially if you have a PC that can be different from a Mac. I guess maybe I should ask, did anyone have issues exporting the plot?
Yeah, actually it did work, but for me, it opened my computer, the folders inside my computer and not my desktop. So that was a bit different for me.
Okay. Were you able to navigate? Because like if you do the tilde / and you hit tab, it will show you what folders you have there. Maybe you had like user or something else before you got to desktop.
No, there wasn't any desktop or user.
Okay. Well, yeah, I mean, we don't have to worry too much about that right now. I just wanted to show you how to export. But when we start working with our projects, this is going to work more seamlessly because we're going to be using a slightly different tool. So not to worry about that, but I just wanted to show you how to export. Okay, so let's see, I guess. For now we can actually skip this RStudio projects part for now and first try the assignment. And if we have time, we'll go back to that RStudio project. So here's your assignment. Let me just, I want you, as I told you earlier, you can choose a different color scheme using that scale _color_ and hit tab to give you all the options. So I want you to play with that and select a different one from what we used. So explore different options and choose one that is different from the one that we saw in class. The same thing, play around with the theme _ and then options of that, play around with that. do a different, you select a different one from what we used in class. I want you to export, so you're pretty much going to be playing with this code here. And when you export it, because I do want you to export it and submit this, I want you to export as plot underscore A1 underscore last name. So make sure to change this to your last name .png. So basically going to be editing this part of the code here. And once you export that, I want you to upload your new plot. So upload this PNG to GitHub. And I just want to quickly show you where and how. So if I come here on our on the GitHub for our class, as we were talking about earlier, we have the issues part. So we can go on issues, and I opened this issue called assignment number 1 plots. You can go in there. You can just like leave a comment, and I believe you can basically just drag and drop your plot in here, and it will post for you. So let me do that for the one that I exported for the class, just so you can see. So this is the plot that I exported from class. I just want to open that so you can see this is the PNG file. I could bring this into, you know, a Word file or a PowerPoint if I want to show this in a presentation or report. So I think we can basically just come here, drag and drop it. Let me see. Let's see if that works. Yep, so that works. So I basically just posted my plot there. This is going to be your submission of this very quick and easy assignment is going to be to upload your plot to ggplot to GitHub. Sorry. So if you, we have here, you know, another 14 minutes. If you want to get started on that right now, you can. And if you finish that, I guess we can stop here as well. And we can go into the RStudio projects part of things in our next class. And I do know that like some people were having issues with installing the packages. Let's see. Maybe it would be a little bit disturbing to the rest of the class if we go through that right now. But I'll be available after class until noon. So if you have issues and you want to go through that, please, and if you can stay after class, we can go through that. Or, you know, set up a different time as well. That works too. Just let me know, because I do want to make sure that you're all have installed the packages for our next class on Friday. So that's going to be important to have everyone on the same page by Friday. And again, so this assignment is pretty simple, pretty straightforward. If you did not have issues with installing packages, please make sure you submit by today. You should be able to do in the next 5 minutes. If you had problems with packages, I know that you are not going to be able to do this because we are relying on ggplot2, which maybe we weren't able to install. So if that was your case, if you had problems with installing packages, let's talk after class, and then I'll give you a little bit more time to complete this as well.